So the question, Mr. Curl wants to fly 100 kilometers north in his ultralight plane that has a maximum airspeed of 50 kilometers an hour. We're going to do question A, which is a very simple one. If there is no wind, how long would it take him? Very simple physics question. We'll start off with that. A, the velocity is distance over time. We're given that the velocity of the airplane is 50 kilometers per hour north, and the displacement that he actually wants to travel is 100 kilometers, and that's north. Now, the trick that I'm just showing you is that, why are we doing that? Well, we can use these two numbers in this formula because they're in the same direction. If they're not in the same direction, even like 30 degrees apart, we couldn't use this formula as is. The vectors have to be in the same direction to use this formula. Okay, so that's the big part of this. Time is distance over velocity, displacement over velocity. It's an easy question, but I'm just going to go through it. And the velocity is 50 kilometers per hour north. And what we end up with is just 2 hours. The units will cancel out, the directions cancel out. That's how we have to do it. Okay, but that was and we'll use that as a comparison. We'll switch to red here for part B, and part B, C, and D all have to do about the new wind that starts at is 40 kilometers an hour to the east. Okay, so at this point, we need to start drawing things. We will have that he wants to go north. No arrowhead there because we don't know the length of it, but we know the direction. It could be that size arrow, that size arrow, that size arrow. It's starting here. What do we know about planes and vectors? Well, we'll take the plane speed. That's not a vector. To make it a vector, we have to make it have a direction, and that's called its heading. And then we have to add the wind speed. And the direction the wind is going. And what we end up is with the resultant. Okay? That's also can be broken down into the ground speed and its direction. So we have to add up two vectors to get to the resultant. We have the resultant here drawn in red. Well, at least the direction of it. We don't know the magnitude of it, but we've got to add two vectors to it. So we add the wind. I know this is not the wind. I'm just giving you an example here. Let's change the colors for the ones we're going to add to be blue. So we take the wind, and I'm going to add the plane. Okay, that doesn't end up along that red line. It has to end up along that red line because he wants, and that's the big word here, to know he wants to head north. So it automatically tells you the answer's direction. So I'm going to take these two vectors and add them together to get the resultant, and it has to end up somewhere on that line. It could end up there, it could end up here, it could end up way up there. But when we add the wind, in this case that's the wind and that's the plane, then our resultant vector would be nice and tall. Can I bring that all the way up? There would be a resultant vector. We just have to add those two. Now, this isn't the wind. That isn't the plane, because I was just telling you the theory behind it. We add the plane and the wind together. I can't get rid of that. We have to add the wind. We're given the wind, and the wind is 40 kilometers an hour to the east. So we draw. There's 40. Now we have to add the plane. And it's 50. Oh, no. It's not any direction. It has to be in a direction that ends up going straight north. Why? It's because what I highlighted there in yellow. He wants to go north, so it has to end up on that red line. So there's the triangle. I can see the triangle. That's the plane. That's the wind, sorry. 40 kilometers per hour. And that's going to the east. Here's the plane. And that is going at 50 kilometers per hour. I don't know the direction yet, but I have the vector drawn. And the ground speed, which is the red, I don't have the magnitude of it, but I know the direction. It's north. But Pythagoras, we can figure out theirs, and we can find the angle. Let's do Pythagoras first, which is going to answer C, the ground speed. The ground speed is the magnitude of the resultant, the red line. Okay? And so C will be the resultant, which is the square root of 50 squared minus 40 squared. And you're right, Alex, it is 30. Because that's 2,500 minus 1,600, which is 900, all square rooted. So that'll be the answer for letter C. Okay, that's the ground speed. If we wanted the whole ground speed resultant, you would put a north in there, because it is heading north. And it better be, because that's the answer, and he wants to head north, and he's heading north. That's good. Let's do B. Now, when you see this vector, it's hard to figure out which angle we want because it's already in a triangle. So I'm just going to copy it, get it out of there, paste it over here, just to envision. If I give you a vector like this, there's the tail of it, and I have to measure the angle. You want that angle that's measured to the horizontal. So then that would be the north of west angle that we want. So that's the angle that we want. Well, it just happens to be in that triangle. Yay. So let's just get rid of that. So we want that angle. So the answer for B would be that's the adjacent, that's the hypotenuse to that angle. So we want to use the cosine. The cosine of 40 over 50, inverse it to get that angle. And let's do the inverse cosine of 40 divided by 50, and that'll give us 36.87. degrees. Now, really, the answer for that is not just 36.87 degrees, it'll be then north of west. And that'll be the answer for the angle, for the direction, which is the heading. Last but not least, D. How long will it now take? Beforehand, it only took him 2 hours. It took him 2 hours to go there, but now there's a 40-kilometer-an-hour wind that he has to fight against. So the new time, the time is the distance over the speed. Now here, hang on, we have a distance still of 100 kilometers north. Which speed do we put in there? There's 3 speeds now. We have 50 of the plane, 40 of the wind, and 30 of the ground speed. We choose the one that's in the same direction. Has to be, because we can't use that formula unless that's it. The only one that is in the north direction is 30. and that'll be 3 1/3 hours, or 3 hours and 20 minutes. So with the wind that kicks up, it takes them another hour and 20 minutes to get there than normal, than without the wind. Please subscribe. Just kidding. Okay.